Alright everybody, welcome to another video, this time on pyramids. So pyramids are a little bit like cylinders because, no, I'm sorry, not cylinders, they're a little bit like prisms because on these shapes there is a base, and that base could be a number of shapes. Could be a triangle, a square, a rectangle, a parallelogram, a trapezoid, could be almost anything. Could be a hexagon even. So, again, these pyramids are going to be named based on their bases. One with a triangular base will be called a triangular pyramid. One with a square base could be called a square pyramid. The nets are going to basically all look like whatever the shape is at the base in the middle, and then triangles of some sort coming off of them. So that could be a net for a pyramid. If it were more of a square shape, it would probably look something more like this. Those triangles would sort of fold up and meet towards the top of the pyramid, at the top of the pyramid. So, formula for surface area. As you saw, we have that base that's there, and we're going to need that as part of the surface area. Whatever the area of that base is, whatever shape it is, that's going to be part of the formula. A shortcut to find the rest of the area, though, is we're going to add 1/2 of the perimeter of the base times the slant height. The reason this works is because if you look at these triangles here, the area formula for one of those triangles would be, whatever the side length is, times the slant height, which is going right here on the triangle, divided by 2. So since there are going to be however many of those make up the perimeter, it's a shortcut if we just use the perimeter in the first place in this equation. Volume is not too tricky for pyramids. All you have to know for the volume is that it's 1/3 of the area of the base times the height of the pyramid. So again, it's going to be important to know the difference between your height and your slant height. Remember, height goes straight up and down from the ground, from the base. Slant height kind of comes in at an angle. All right, let's start with examples then. So a regular square pyramid has a height of 15 centimeters and a base edge length of 16 centimeters. Find the surface area and volume. All right, so we are going to find the surface area and volume of this pyramid. Let's start with surface area. We need the base plus 1/2 of the perimeter times the slant height. We do not have the slant height yet, but we know that from this height here, which is 15, if we go to where the slant height meets, notice that we're forming a right triangle. We know the height is 15, and since this is a regular shape, we know that from that height that's going straight down, we're going to be halfway over, so we're going to have a length of 8 on the bottom, since the full length we know is 16. So now we can do Pythagorean theorem. So we are going to do, in this case, 15 squared plus 8 squared equals x squared. 15 squared is 225, and 8 squared is 64. If we add those together, we get 289. X squared. Square root of both of those will tell us that x equals 17. So that's our slant height. So now we are ready to calculate the surface area. Area of the base is going to be, since it is a square, we know that all sides are 16. We know it's a square because it tells us right here. So 16 times 16 gives us 256. Plus 1/2 the perimeter of the base will be that 16 repeated 4 times, and 16 times 4 is 64, times the slant height, which we just calculated was 17. So if I do 256 plus 0.5 times 64 times 17, we discover that the surface area is 800, not 880, just 800 centimeters squared. Volume is easier. We need 1/3 times the area of the base times the height. We have all these numbers at this point, so it's going to be 1/3 times 256, which is our area of the base, calculated in the surface area, times the height, which is 15. So 1 divided by 3 gives us 0.3 repeating, times 256 times 15. And that gives us 1,280, and this is going to be centimeters cubed, since we're using volume. So there's that problem. Let's look at the next one. Find the surface area of the regular hexagonal prism. So, surface area is the area of the base plus 1/2 the perimeter times the slant height. We're given the slant height this time. We know it's 14. And if you look, we're given everything we need to be able to find the area of the base of the hexagon. We know that the apothem has a length of 5√3, and that the base of one of these triangles is 10. So to find the area of one of the triangles, we'll just do 1/2 of 5√3 times 10. That gives us, so 0.5 times 5 times √3, close that parentheses, times 10, gives us 43.3. And we know there are going to be 6 of those triangles, so we'll just multiply that by 6 times 6, and we get 259.8 as the area of the base. So I'm going to put that right over here. And the rest is going to be simple. Plus 1/2. The perimeter of the base is going to be that 10 repeated 6 times, so it's 1/2 of 10 times 6, which is 60, times the slant height, which is 14. And we're ready for the calculator again. So 259.81 plus 0.5 times 60 times 14 gives us a surface area of 679.81, and this is going to be feet squared. So, problems involving those regular polygons are not so bad when you're given the apothem and the side length. There's not all that much work except to use the formula. All right, next one. This 9 right here is the height of the pyramid, so that's good to know. Our volume equation is 1/3 of the area of the base times the height. Well, the area of this base is going to be a triangle. It's going to be 1/2 of 4 times 6, which is 1/2 of 24, which is 12. So we have 1/3 of 12 times the height, which is 9. 1/3 of 12 is 4. 4 times 9 is 36. And we're dealing with volume there, so it's meters cubed. Okay, so here we have a pyramid from Egypt. It has a height of 144 meters, and look at that volume. Lots of cubic meters in there. So we need to find the side lengths of the base, the individual side lengths. Well, remember that volume equals 1/3 of the area of the base times the height. We're told the height, and we're told the volume. So 2,226,450 equals 1/3 times the area of the base times 144, which is the height. From here, it might be helpful for us to combine the 1/3 and the 144. So 1/3 times 144 is 48. So this is really going to equal 48 times the base. And here we have 2,226,450 again. To get the base by itself, we divide by 48. So 2,226,000 divided 450, divided by 48. So we get that the base is about 46,384.38 meters squared. Now remember, the base is a square, and we want to know one of the side lengths of that square. So here's x, here's x. The area of the square is going to be that x squared. It's going to be that side length squared. So to find the side length, we just have to take the square root of the number that we just got. And the square root of the number that we just got is about equal to 215.37 feet. So that would be the side length of the pyramid. Last but not least, one of these problems that has two shapes in it. We have a cube on the bottom and we have a pyramid on the top with a square base. So let's just set up the formulas for the surface area and volume first. So for surface area, since it is a cube, we know that these 6 sides are going to all be identical of the cube. The only thing we need to keep in mind is that this one on top, this one right here, is being covered up by the pyramid. So we're not going to want to include that. The area of one of these sides, since it is a square, is going to be 6 times 6. That's the area of one of these cube sides. And we want 5 out of the 6 of them. So what we're going to do is we're going to take the 6 times 6 and multiply that by 5, and that will give us the surface area of the cube. From the pyramid, remember the pyramid has 2 parts to a surface area. It has the base, and then it has the 1/2 perimeter times slant height. Well, we're not going to need the base area because, again, that's this cube. That's the base of the pyramid. So we don't need that part. The only part that we need is the 1/2 p times slant height. Finding the slant height, what we need to do is set up one of those triangles again. We know that the height is 6 meters. Since we're cutting this down the middle with this height, we know that this is going to have a length of 3 meters, and now we just need the hypotenuse. So 3 squared plus 6 squared gives us that missing side. 9 plus 36 equals x squared. 45 equals x squared. Take the square root of that, and we get that x is about equal to 6.71. 6.71. Right there. Okay. So, and also we can calculate the perimeter of this base. 6, 12, 18, 24 is going to be the perimeter. So it's going to be plus 1/2 times 24 times our slant height, which was 6.71. So here's the cube. Here's the pyramid. 6 times 6 times 5 is 180. So it's going to be 180 plus what we have over here. So 180 plus 0.5 times 24 times 6.71. And we end up getting about 260.52 meters squared. Volume, again, is going to be a little bit easier than surface area was. We just need to get the 2 volumes and add them together. So the volume of the cube is just going to be area of one of the bases, which would be 6 times 6, times the height, which is also 6. This is for the cube. The area for the pyramid is going to be 1/3 of the area of the base, which we said was 36, 6 times 6, times the height of the pyramid, which is also 6. So 6 times 6 times 6 is 216. And 1/3, that's 0.3 repeating, times 36 times 6 gives us 72. Adding 216 and 72, we get 288, and it's going to be meters cubed. So there you have it. The formulas that we need for pyramids and how to use them, and even some more complicated problems than that. So hope you learned something in this video. I'll see you in the next one.